A very good morning, ladies and gentlemen. Day 2 of the Danube Ports Days 2023. Welcome to the online participants as well. Please take your seats and let's get it started for day 2 as well. My name is Robert Raphael. For those who have not been here yesterday, a short introduction, housekeeping rules. As usual, please mute or at least put your mobile phones into the silent mode. Emergency exit, which we will not need to use, is the door where you were entering. Toilets from this direction are both on the left-hand side. First door is for gentlemen and the second on the left is for the ladies. Today is Black Friday, but we are still discussing about green Danube ports and green inland vessels, so don't be surprised that we will not use the black word anymore today. What is it today? Yesterday we were discussing about ports, or mainly about ports and all the aspects related to sustainable management of ports, logistics procedures, digitalization, and we have seen quite some demos progressing in the framework of the multi-reload project. And during the user forum, we did not record all the speeches and the bilateral dialogues, but I'm pretty sure that you were continuing to discuss those demonstrators, and Herfried will also have a solution soon, because I guess the Open Innovation Challenge also took place on his birthday during the discussions. So once again, thank you for all yesterday, all the crew, the team, and the participants. And same is expected for today. In the early morning, we just had a quick board of directors meeting of ProDanube International. I need to say they are happy with the things what are happening in the past 2 days. Today, we have basically 2 main blocks. The first block is orchestrated around the SYNERGETICS project, with which we will be discussing about technologies to be applied on vessels. But obviously, each and every vessel will come at a certain moment in time to a port, especially when it's about bunkering, especially when it's about taking up some kind of alternative fuel. Maybe today we will learn what's going to be the fastest and most available. And then after the session, after this SYNERGETICS project session, we will have 2 more presentations coming back bit closer to the ports, but I think we will also not navigate too far away from the ports. And the day is to be concluded around 12:15 when it comes to the presentations and the content. And after that, we welcome you again for a networking lunch. And then you can enjoy the afternoon in the Black Friday. So once more, black. I think we were very, very good on time yesterday. Thank you for the speakers and all the co-moderators. We expect the same today. No stress, Igor, but we have an eye on you. And with that, I think I can only just invite Igor Bachkalov to the stage, who will have a presentation on the SYNERGETICS project in general. Afterwards, he will take the floor, similar as we did in the multi-reload. The project master takes the floor to moderate his partners in the project. There will be presentations, and afterwards we will ask for a half a second patience. We will move those high tables inside, and there will be a panel discussion. Yesterday, we also did some first of its kinds, at least for us. Today, there will also be a first of its kind. One of the speakers and participants to the panel discussion will be there remotely online. So I think that will work out also perfectly, thanks to the technical team in the background. So without further ado, Igor, the floor is yours. Igor is the project manager for the SYNERGETICS Innovation Action. He is with DST in Germany, and the floor is yours. Thank you, Igor.
I like to have eyes on me. So, good morning. First of all, let me start by saying thanks to the organizers who made a slot available for Synergetics. Thanks to Robert, thanks to Herfried, and my personal thanks goes to Immanuel. I know how much effort he put into assembling the panel for today. Thank you, Immanuel, for your efforts. My name is Igor Bachkalov. I come from DST. DST is short for Development Center for Ship Technology and Transport Systems. It is a research institute in Western Germany, which focuses on inland navigation and coastal shipping. And DST started some 70 years ago as a towing tank. But in the meantime, it significantly expanded the scope of its activities. It is still a reference institution for the shallow water hydrodynamics, but we also host a range of other facilities. So in addition to the model test basins, we host a remote control center, a suite of the full mission bridge simulators, and as of recently also a port research lab where we focus on the automation of port processes. So that would be about the DST, who is also the coordinator of Synergetics. We are going to have 5 presentations, mine included. And the ambition is that towards the end, we have, say, sometime 15-20 minutes more better for the discussion. And I would like to encourage you to ask whatever you would like to ask. The idea of bringing Synergetics to the Danube region is actually one of the core ideas of the Synergetics itself, and I'm going to reflect on that during my presentation. But we are here because we want to introduce what we are doing to the Danube community and to get the feedback from the Danube community. Before we start with the presentations, we have basically it's a cartoon. It's an animated movie which digests, I would say, in an aesthetically appealing way what the Synergetics is about. So I would like to ask the technicians to roll the Synergetics animation, and after that we are going to continue with the presentations.
Sustainability is playing an increasingly important role in coastal and inland shipping. We all strive for a cleaner world and the mitigation of climate change. Therefore, we need to take short-term measures to reduce emissions. However, transition to sustainability takes time, knowledge, and expertise. This is where the project Synergetics steps in. Are you interested in what Synergetics could mean for the future? The waterborne transport sector faces significant challenges to meet the emission reduction ambitions of the European Green Deal. Synergetics contributes to the sustainability of a large existing fleet of coastal and inland ships, as ships will have to become increasingly clean and use more and more energy with a low or zero carbon intensity. Various solutions are being considered, such as the use of hydrogen, methanol, and swappable battery containers. Unfortunately, these options still lack in terms of costs and practical applicability. Due to the specific navigational routes and diverse types of cargoes they transport, a tailor-made approach is needed to take into account the characteristics of the particular ship and the operation. To facilitate and accelerate the green transformation of coastal and inland shipping, it is needed to bring together necessary expertise and capabilities. This is where Synergetics will make a difference. The project started in January 2023 and will run until June 2026. Throughout the project, Synergetics expects to have acquired sufficient expertise and skills to provide tailor-made advice to ship owners. Synergetics is made possible by the European Union and is executed by 19 project partners of the following types: research institutes, innovation centers, shipbuilding companies, regulatory authorities, ship owners, and technology suppliers. Due to this unique collaboration, it is possible to accelerate the sustainability of the coastal and inland shipping industry. SYNERGETICS will demonstrate the use of clean engines running on hydrogen and methanol, the electrification of the main drivetrain, the benefits of hydrodynamic improvements, the use of the swappable battery packs, and the improvement of energy management systems by means of retrofit on existing ships. The knowledge how to reduce greenhouse gas and air pollutant emissions are being brought together in SYNERGETICS. The ultimate goals are to create a catalogue of greening solutions, to provide up-to-date scenarios for policymakers, as well as to make available a practical decision support tool and handbook to ship owners for making the right choice for greening of their ships. The project is an innovation action funded by Horizon Europe of the European Union. The project has a total budget of 7.2 million euro. The European Union contributes 4.2 million euro to the budget. Contributions from the governments of Switzerland and the United Kingdom are also involved. The remaining part is covered by own contributions from the private partners in the project. SYNERGETICS respond to the call, transformation of the existing fleet towards greener operations through retrofitting. It kicked off on the 8th of February 2023 at DST, Development Center for Ship Technology and Transport Systems in Duisburg. An important activity of SYNERGETICS is promotion. The outcomes will be available to interested parties through different dissemination channels, such as the website, LinkedIn, scientific publications, events, and by means of direct involvement of the stakeholders. Although the most significant developments take place in Western Europe, the outcomes of SYNERGETICS will be disseminated all over Europe, where significant coastal and inland transport exists. SYNERGETICS, creating synergies for green transformation of inland and coastal shipping.
Okay. Right. Can I have the presentation now, please? Right. Well, I'll try not to repeat all the data from the presentation, but I'll try to elaborate some of the things that were mentioned here. And the first thing here is that we need to notice that this is an innovation action. So for those who are not quite acquainted with the landscape of European projects, an innovation action is a very specific type of a project which requires a high TRL to be achieved towards the end of the project. So we're talking about TRL 7, 8, 9. And this means that the things that we are going to develop, the solutions that we're going to develop in the project should be, ready to be deployed once the project is over. And this means that high involvement of industry is required because the research institutes cannot do it by themselves. We need to involve industry who is actually providing the solutions. That said, the conditions for the industry participation are not terrific because the refund rate is up to 60%. The industry, the for-profit organizations are eligible to recover up to 60% of their costs, and actually the equipment costs are subject to depreciation costs. So it may not even be that as well. So it's quite a challenging framework to make a project like this. You need to aim for a lot. You need to engage those who are capable of delivering, and you need to engage them in a way which does not sound to be very attractive for them. And as you have noticed from the animation, it's the total value of the project is 7.2 million euros, but the European Union contributes with a little bit over 4 million, and the rest comes from, something comes from the UK and Switzerland, but actually the most of it comes from the partners themselves, so from the industrial partners who invest their own money in the project. So the question is now, and I think you have noticed also from the roll-up there, but also from the presentation and the animation, you have noticed that we actually managed to engage quite a lot of industrial partners. And I'm happy that some of these partners are today with us here and that they're going also to present their solutions. Now the question is how? How did we manage to do that in such a challenging framework? And this leads us actually to the concept of synergies. We understood very early in the proposal phase that we are dealing with a complex issue in the sense that the ships which are, the inland and coastal fleets are consisted of ships which are very different in types, in sizes, in operational profiles and so on. And this means that cannot be, one solution that fits all. So we need different solutions for ships of different sizes, types, the way they operate and so on. That's one thing, but then the question was, okay, how do we fit this into a single project, and how do we, do it by ourselves? No matter how big your consortium is, you cannot pull out everything. But then, in the same time, we realized that there has been, already a lot of knowledge and already a lot of experience available. So there is a lot of knowledge available made through different projects. At the research institutes, the knowledge centers, and so on. And we needed to gather this knowledge in one place, in a consistent and coherent manner. And then, on the other hand, we also realized that there are many pilot projects executed in the past, or ongoing pilot projects, or also pilot projects which are being planned at the time when we were submitting the proposal. So we understood that we could benefit also from the experience which is gathered from these pilots. And then we said, okay, let's try to establish living connections, these synergies between the different stakeholders, between knowledge centers, research institutes, industry partners who are carrying out or carried out the pilots, and try to gather all the knowledge and expertise to streamline it, if you like, and to gather it into one place. And this is the concept of synergies, which is the backbone of the SYNERGETICS project. Now, another thing that I would like to reflect on here is, you see, we mentioned the synergies between different regions. We have understood also in the preparation phase, but also we discussed this several times since the project started. There are actually number of countries where these innovations are taking place in Europe are, less than 5. And then there is no substantial transfer of knowledge from one region to another, and that we actually sometimes tend to forget that we have a 2,400 kilometers long waterway which connects 10 countries and extends through half of the Europe. And somehow it seems that it's not there on the map. It's very difficult to establish where does the Europe start and ends. So we wanted to change this. Of course, it's a high ambition, but we can contribute by starting to, initiating the transfer of knowledge from one region to another. Now, that said, it leads us to the activities that we are carrying out in the SYNERGETICS. And actually, we have, as you can see on this slide, we have an activity which is called exploration. Exploration is actually referring to gathering this available knowledge. So the knowledge that research centers and knowledge institutes already have. It's not just an inventory. So we're not talking about, let's say, a static activity. It is a rather a dynamic activity. We start from something that we already know, but we keep on updating throughout the project because we learn from each other. That is the synergy. That is this living relationship. Then we have another activity which is called synchronization, and that is an activity which is dedicated to gathering the experiences from the pilots. And finally, we have the demonstrations of our own, because the innovation action has to have demonstrators. And we are going to demonstrate several things. I will reflect on that a little bit, or actually on the next slides already. These three sources of knowledge that we gather from the exploration, synchronization, and our own demonstrations, they're all streamlined into integration. They are integrated in the activity where we make what we call a catalog. We make a catalog of the solutions, and then using this catalog as a basis, we provide the tools where we target two groups of users. We target vessel owners, and we try to provide a decision support tool for the vessel owners. You come to SYNERGETICS entity, and you say, okay, I have a ship of this size. We carry chemicals, so we travel on that route, and we provide some operational profiles of our own. And then the idea is that we can provide you, let's say, a solution that fits you the most. And then we target another group of users, the policymakers. We try to, based on the experiences and the knowledge that we have gathered, we try to influence, in a way, the policy, the direction of the policy in the future. We have our own demonstrators. I think I'm missing a slide here, but never mind. We have what we call full-scale demonstrators, system demonstrators, and model-scale demonstrators. The full-scale demonstrators are actually one full-scale demonstrator is demonstrating the use of hydrogen in internal combustion engines. Another is demonstrating the use of methanol in internal combustion engines. We have a demonstrator where we are exploring the electrification of the main propulsion plant. This is what you see on the left-hand side. And we have a demonstrator where we show the capabilities of the battery, swappable battery systems. It is already, it is already developed, but the SYNERGETICS is there for zero-emission services to advance their system and to improve it from the technical point of view and from the operational point of view. Apart from the full-scale demonstrators, we have, seriously, I'm missing a couple of slides here, but okay. We have model-scale demonstrators. The model-scale demonstrators are, we employ the testing facilities that we have available within the consortium. We are using the towing tank at DST, where we're exploring a specific technology which is called aft ship replacement. So we're looking into the hydrodynamic improvement of the aft ship, and we are also, while we are improving the aft ship from the hydrodynamical point of view, we can also alter the machine room and make it suitable for some other technologies, and it is very, very efficient technique. And we are also using the testing facilities, actually a zero-emission lab of Maritime Institute in Netherlands, MARIN, where we are going to look into the best solution for the retrofit of one of the boats of our partner, Viadono. They have a brand new push boat that they would like to retrofit in future, and there we are going to look, we are going to deploy the digital tools, looking into using the simulations, looking into the best possible solution for their push boat. Then we have what we call system demonstrators. There we are looking into improvement of some technologies. On one hand, we have a demonstrator which is going to be carried out by our partner Skandinaus. Bengt Ramne is here. He's going to talk about the use of methanol as a fuel. They're going to look into different ways of employment of methanol in internal combustion engines, and they're going to compare. So it is, I like to refer to this as perhaps the most scientific part of the SYNERGETICS, because we are, putting things on a level playing field and really looking into the pros and cons of different ways of using methanol. And on the other hand, we have future-proof shipping, also one of the partners in the SYNERGETICS, who is looking into development of the second generation of the power management systems for the ships which are using the hydrogen and fuel cells. They already have the first generation of the systems. They have one vessel, I believe, which is already sailing. The next one is due very soon, and then there will be a third one. And by using the operational data from these vessels, they want to develop a next generation of power management systems. So these are the demonstrators that we are going to deploy throughout the Synergetics. Now, as I said, the ambition is to integrate this knowledge and to make a catalog of retrofit solutions, and using this catalog as a basis, we want to develop tools. Tools are here shown in these green fields. We have a decision support tool, which is related to the handbook for implementation of greening retrofit technologies. And we have tools which are leading to updated scenarios for the policymakers. So we are targeting two different groups. That would be, let's say, this presentation is called Status and Ambition, so this is the ambition that we were talking about so far. Let's see what's the status, just briefly, because I think I'm already stepped over the boundaries. Robert keeps looking at me. So I will just quickly go through some of the updates. In this synchronization phase, we have, I think we have one really nice achievement, which is going to be publicly available very soon. We have managed to gather something that we call the pilot database, because people are talking. There are pilots here and there. People are exploring the possibilities, sometimes through their private initiatives, sometimes publicly funded, and so on. But we really don't know actually what kind of technologies are being tested as pilots. What kind of pilots do we really have? And there was no single database about this. And one of the achievements of Synergetics so far is the pilot database. We have a database which has, I think, more than, initially it had more than 180 entries. Now we are slimmed down to 150 inland vessels and 50 coastal ships. And it is the most comprehensive and up-to-date database to our knowledge available, and it's going to be publicly available. This database, well, this is a composition of the types of the vessels. The letters are too small, but it doesn't matter at the moment. This database is helping us to understand what are the trends. So what are the most preferred technologies which are being used as pilots? What kind of alternative fuels are being used? Are there more electrifications or sustainable alternative fuels being used in the pilots? What about the energy efficiency measures? What are the trends with respect to the timeline, and so on? And also I would like to reflect on something very specific here. We said that we are going to use the available knowledge when we are striving to develop this catalog. And there in the exploration phase, we need to remind ourselves that we already have some sort of a prototype of the catalog, which has been made during the Grendel project in cooperation with Danube. And there we have also targeted two groups of users, because through these fact sheets that you see on the left-hand side, the vessel owners are being targeted by, explaining what are the capabilities of the technologies and how these technologies can be used. And on the right-hand side, we have this, I would say, quite a nice result, this state aid scheme, which has been developed actually by Danube, which was actually targeting the policy makers. So we have a sort of a nucleus, and I like that this sort of a nucleus of the catalog actually comes from the Danube. That's a nice part of nice twist in this story. Okay, so that would be it from me for now. I would like to give floor to Jan Andreas, our colleague from Argo Anlink. He's going to tell us something about the way they're employing hydrogen. So Jan Andreas, please.
Thank you very much for the invitation and the possibility to present here on this meeting our solutions for hydrogen. We are not political people. We are just people who are doing. We are, perhaps my name, Jan Andreas. I worked, before I started my company in 2001, I was engineer in aerospace industry, designing injectors for Ariane and test bench valves and hydrogen supply valves for the Ariane rocket, so coming from high pressure and larger flows. And I'm quite linked also to the ship industry. My first ship I did was the hydrogen supply and oxygen supply for the German submarine. At this time it was HDW called, but today it's ThyssenKrupp Marine Systems. So I have a little bit of knowledge. We are known as a company who is implementing things, who is just doing and bringing it on the market, showing that hydrogen is today a possibility to decarbonize. And if I look at what has been said several times today, 2035 we want to decarbonize, and then I look at the quantity of vehicles, of ships we have to decarbonize until 2035. Sorry, I have customers. One of my customers has over 180 ships. So if we start in Germany, that's special. It's taking 2 times to get fundings or to get it through the paperwork. So that means 25, and then 10 years left, 180 ships. That's 18 ships per year. So we have to start now if we really want to take it seriously, and that's what we are doing. So we are transforming all kind of vehicles. This is for Mercedes. We did the 80-ton just to prove that it's working, and it's not only a one-off. It's one of our rare projects where we not only make prototypes but small series. Next step is 50 units of these 18-ton trucks. We are making, as a small company, also refueling stations, because we have an overall approach. The customer is logistic companies. They don't know how a refueling station works, and they for sure don't want to know it, but they need it to refuel their trucks. So we are bringing overall solutions. That means that we make refueling stations. We are also working on electrolyzers, and we have done interesting projects, and it has nothing to do with the SYNERGETICS project, but it's synergy is to use one thing to do several to solve several problems. And the electrolyzer is a very nice example. We have done a research project with Stadtwerke Kaiserslautern. You know that in Germany, the Stadtwerke, they own the electricity grid, so they own the wind parks, they own the water treatments, they own the buses, they are running the buses to bring the people from A to B, and they run the swimming pools. Swimming pool is an awful hole where you can put a lot of money in, and it will always be too expensive. So we did a project where we showed that with an electrolyzer, if you use it in an intelligent way, this means you take green electricity, you produce hydrogen. Hydrogen is the byproduct. We produce oxygen for disinfection to produce ozone for the swimming pool. The excess heat of the electrolyzer we use to heat the swimming pool. The rest of the oxygen, which is not used for the ozone production, we use it for water treatment, so reducing the energy consumption of the water treatment. And then we have a byproduct, which is hydrogen, which we put into buses. And suddenly the costs of the hydrogen and the running costs of the hydrogen buses is much lower, because a huge part of the investment of the electrolyzer is used to fill financial holes of other projects. And that's quite interesting approach, which brings us to the consumers of the hydrogen. And we have done interesting projects like a mine truck for South Africa for decarbonized mining, in open air mining, so that's very ecological thing. But it was for us the first time we implemented 1.2 megawatt into a mobile application. So that was really an interesting project, learning a lot about also using excess heat to preheat the hydrogen, etc., etc. And then these are all projects we have realized in the last couple of years. That means 60-ton truck, 40-ton truck Volvo, which also run in Kiruna at low temperature tests. Due to climate change, we didn't have -40, we only had -27, but it fully worked. We have done the MAN trucks, ICE truck, that means internal combustion engine truck, and the fuel cell truck. So we can now compare the fuel cell trucks and the ICE truck. We did the transformation of the battery crafter because Volkswagen found out that the battery crafter is not suitable for professional usage, because 90 kilometers maximum speed, 120 kilometers, I know from the statistics that no crafter runs more than 100 kilometers, they are all below. And of course the supplemental weight, if you have a battery crafter, is not possible. We transformed it to hydrogen, 127 maximum speed, range is 400 to 450 kilometer full load. Yeah, refueling time 3 minutes, so very easy, but due to strategic change of Volkswagen, they don't want to produce it anymore because they have a battery strategy, but that's now on the political side. And again, 18-ton trucks, which are available, which you can purchase, and we can sell them with the refueling station infrastructure. We also converted snow groomer, decarbonized skiing in the Dolomiten with an Italian company, Prinot. It's for us an interesting project because then we learn off-road applications. We are also making a refueling station for this snow groomer, so it can be refueled. It's just experience. And then we come to the next problem. Very often, and especially on harbors, you have vehicles which are not so much suitable to go to the refueling station. So we developed, the first one was in 2014, mobile refueling station. That means that not the vehicle is coming to the refueling station, but the refueling station is coming to the vehicle, allowing to have several spots where I refuel my consumptions. And we have, this is the one where I went to Sweden with it to do first refuelings of the 40-ton trucks and the 60-ton truck from Volvo, and we are currently building up a huger truck for refueling with 500 kilogram for a maritime application in South France. So with one truck we can refuel several harbors, which are Nice, Cannes, Monaco, up to Marseille, Toulon, and yeah, that's we're currently building. That's a Donau project. We are very proud. We are waiting for the fundings, which is something quite usual in Germany. It's a Donau Prinzessin. It's a passenger boat similar to what we have used yesterday, and we passed through the certification. So now we are waiting for the funding to realize this project. One of my first push boats was the Electra push boat, which is running in Berlin with 300 kilowatt fuel cell system, battery pack, and hydrogen. And that's I developed the first time I had the idea to develop so-called H2 tankteners or cartridges. That means that I bring the bunkering process away from the harbor to the inland, and I just have a logistic. And creating containers, as you see it here when you look out of the windows, is something which I used on ports. So I don't need a refueling station on the harbor. I don't have a bunkering process. I just swap containers, which is quite easy, quite quickly, and which works quite fine. So we implemented and we show that it works on the Electra push boat. We have the hydrogen boat for the harbor passenger taxi boats ready. We're just waiting of hydrogen infrastructure to transform these boats with the similar principle to fuel cell. For regulation, you need, of course, two systems. So if one shuts down, you can run the other one. And hydrogen supply, that's one of the, just showing you examples which are possible today. We can start with this kind of boats. We can start offshore working ships for offshore wind park platforms. Yeah, we pass through DNV and CESNI, and that's interesting for me, for an engineering company which wants to produce things. We suddenly become specialists in certification and regulations and normalization. So we are also mandated from a few Rhine shippers to work together with the DST to work out regulations, or how could hydrogen systems be implemented on different kind of ships. Means cargo, container, gas carrier. Where do I can place the hydrogen system so that it gets classified and certified by regulations. Other applications like houseboats, very interesting project. It's more demonstrator, but decarbonized tourism is coming more and more. And we also have luxury leisure boats. You know, more and more people wants to have nice fun with a boat. 40 full carbon boat, high speed with hydrogen system. with an ecosystem, so the hydrogen is produced on site, and during night the boats are refueled. In Mediterranean regions, 80% or 90% of the boats always sleep at the same harbor, so you only need one infrastructure to refuel these boats. That we built one 2 years ago, and we are now building 4 for the Olympic Games in Paris. 90 feet catamaran, also for passenger transportation, we are currently realizing. And now we're coming for you more interested we are currently building the Renus Mannheim with 800 kilowatt of fuel cell. And here we applied the same system like you can see here. These are, oh no, it's on the next slide, sorry, is the hydrogen supply. To make it easy, we made 20 feet containers, which can be swapped off the vessel. And the fuel cells are in this open space compartment. That's because of regulations that makes life easier. And this ship will start to sail in January. So today it is possible to transform these ships. And we are currently planning the next ship, which will run end of 24, beginning of 25. It's a 1.2 megawatt container push boat, which will run also on the Rhine between Rotterdam and Duisburg. And that's our specialty. We do the full package. We do from the hydrogen tanktainer to the gas system to the implementation of the fuel cells, everything from one hand. And on this project, we also look at the hydrogen supply. And that's now the interesting point, that if you have this kind of users, which are pushboat Renus Mannheim will approximately need 2 tons of hydrogen every 100 hours. So with the tanktainer, which I have to bring to the harbor, I have a big consumer of hydrogen. So the investment in an electrolyzer, you are not investing in a small one, you invest in a big one. So the economy of scale is there. And we can produce hydrogen today, purchasing the electricity at 10 cents per kilowatt, which is quite expensive still. We can produce hydrogen for €6.50. €6.50 corresponds to the energy costs of if you run the ship with diesel. So if we are at €6.50 today, we can run a fuel cell ship cheaper, and we can also run an 80-ton truck. We can run cheaper than on hydrogen. Than on diesel. And now that's the interesting point. So the economics works today. Yeah. Of course, we have more costs for the hydrogen system, but this also is quite clear that if we scale up the production, at the moment we are producing 10, perhaps 20 fuel cell systems a year. But if we produce like diesel engines, 100,000, and that's the value which is coming from the Chinese, because they are scaling it up at the moment, then the more costs of the fuel cell system will be negligible. Yeah, it will be not seeable anymore. So what does this message mean? We can, OPEX, run a ship today. If we have 10 cents per kilowatt electricity, we can run a hydrogen ship as expensive as a diesel ship. If we scale up now the quantity of fuel cell system, and 100,000 is not so much, then the capex cost, the investment costs of the system will also be cheaper. And that's why I say in 2035 is very quickly. So we have to do it now, and we need special fundings for the moment to close the gap between the more costs, so that for the users who are transporting companies, they need support from the government to close this gap until we have the volume markers. And it's a bit for me frustrating because the Chinese are closing this gap, and I'm afraid that all this technology in a couple of years will come from China. That's very, very important. And now, for the hydrogen tanktainer we designed for the ships, there's another business case, because the ship is 100 hours or 120 hours between Rotterdam and Duisburg, as an example, on the water. So it will not need these tanktainers, but it needs minimum 2 sets of tanktainers, because one set is on the ship and one is at land at the refueling station and is refueled. The refueling time is 2 or 3 hours, so that's nothing. And I can build up with this tanktainer at the harbor, I can build up a very cheap refueling infrastructure for the vehicles or the applications I'm using on the harbor. Yeah, and during the ship is sailing from one point to the other, I use this hydrogen supply system for the ships to refuel my trucks, my forklifts, my electrical generators, or whatever else. And when the ship is coming, then I organize, and that's only logistic, and that harbors can do. Yeah, I organize a full set at the Hafenkante, put it on the ship, take the empty one, bring them back to the refueling station, and then here we go again. And then also I share the investments of one expensive tanktainer in using it on several applications. Here I have the example of a low-cost dispenser where I don't need compressors. I just need eventually, it's depending on the pressure rate, I need eventually a chiller, but I can make a very cheap infrastructure of refueling different applications. And I just calculated an example. I can refuel 10 vehicles at 350 bars using all the 4 segments. That's technical details now. So it's technically absolutely feasible and makeable. And now for harbor application, we also make hydrogen generators, electrical generators, for example, for recharging ships during night or doing the electricity of the ships during the night. So yeah, that's now fuel cell systems, and yeah, so I just made it in the time. Questions?
I think we leave the questions for the end because we need to run a little bit. Thank you very much. I think we've seen quite a lot here, and one of the... you bet. But the thing is that one of the synergies that we wanted to establish is to learn from the other industries, because shipping is an ancient industry, and it's also very inertial, to say so, and other industries are very often more advanced, and this is what we can learn from the other industries. But there is more to this, and I hope we will have some time for the discussion. Our next technology in line is methanol. Bengt from Skandinavius is a pioneer. He's actually the first person that I have heard talking about methanol on ships. Maybe it's me, but okay. Bengt, please. The floor is yours.
Right.
Speed up.
So, yes, good morning. And thank you, Igor, for the introduction. I will sort of try to do this as fast as I can. Anyway, my name is Bengt Ramne. I'm managing director of Skandinavius AB. We are originally a naval architectural company based in Sweden, in Gothenburg, but we have some presence on the continent as well, with now ship and boat design in Trieste and in Barcelona and in Split. We were established in 2005. We are always been committed to improve shipping and reduce the environmental and climate impact from shipping. And ground zero for us when it's come to methanol is the F-ship project. I will come back to that. In the F-ship project, we looked into different ways to reduce the environmental and climate impact. We put sails on the ships with exhaust heat recovery, exhaust gas cleaning, but we also realized very quick that the big thing is the fuel. So if you want to do something, you have to replace the fuel, find other ways. So we did an extensive mapping what fuels that were available. And of course, starting with the existing fuels based on oil. And there was a time in 2009 when this happened, that everyone was pushing LNG. And we thought gas was good, but it has a problem on ships. So we were looking for other ways. But anyway, we don't have to go through this, but this was where this analysis then ended up with methanol. We thought that methanol is a good thing to look for. We were not the first one. There were some great minds already considered methanol as an alternative to fuel, to oil. This George Olah is a Nobel Prize winner. So we shared we got some inspiration, and we took his thoughts. Anyway, why methanol then? It's a clean burning alcohol with no sulfur and low emissions of particulates and nitrogen oxides. It has a good potential for being produced from renewable feedstock. It's biodegradable and does not bioaccumulate in the aquatic environment. It's a liquid, which is important when you carry a lot. When you need to carry the energy, it needs to be in liquid shape. It helps at least. And it's easy to transport. It's liquid in normal conditions. That's important things for us. So we, again, this F-ship project was the ground zero. We did this project together with Stena, Wärtsilä, SSPA, and a number of other companies. And we pitched the idea, we identify the benefit of methanol, and we got Stena to sort of consider it as a good idea. So we got them to support a number of pilot projects. The first was Stena Scanrail, and after that we did the Stena Germanica conversion, where we actually converted this second largest Ropax vessel in the world to methanol. There was 4 Wärtsilä engines that was converted to methanol. At the time, we were acting as the naval architects, the system integrators, so we did everything except the engines. That engines was done by Wärtsilä. But we developed the design and all the systems around it. About the same time also this Mary Joan was built. That's a product tanker with a 2-stroke engine delivered by MAN. So at that time, really things happening. We were really getting going with the methanol in at least the seagoing shipping. Then, as a challenge as a naval architect, when you introduce something new on a ship, you have to convince everyone you take care of the risks. One concern with methanol, it's a low flash point fuel. It's 11 degrees, and typically for ship fuels, it has to be 60 degrees in order to fit into the regulations, which meant that there are some considerations you have to do, and of course, you have also to prove that what you're doing is right. At the time, when we started this, there were no rules for methanol, which someone thought was a problem. We thought it was a benefit, because then, well, we set the rules, but you always have to convince clients, authorities, and class that you're doing safe things. So apart from the low flash point, there are some other concerns that methanol, when it burns, it's a clean burning, which is good, but it's also so clean burning so you don't actually see it when it burns. So you have to be aware of that, so you have to have other ways to detect if you have a fire. And there are different ways to approach a fire suppression. It burns in a different way. It's not always a worse way, but you have to just be aware of the situation. And then we have the issue with material compatibility. It's corrosive for some materials, and for polymers like gaskets, sealings, what works with diesel might not work with alcohol. But that's just general engineering work to do. You have to go through it. So that was things taken care of, and that's then the Stena Germanica, where we then adopted this new knowledge we had. And changing from diesel to methanol, you can make it very complicated, it become very expensive. But if you do it carefully and you really identify the risk and try to be clever, it's not that big deal. You can actually make a conversion of a ship within reasonable cost, and particularly much cheaper than any other alternative fuels. Stena Germanica, 4-stroke engines delivered by Wärtsilä for the big ships. Mary Joan, 2-stroke engine delivered by MAN. So with those 2 projects, we sort of have got the ships, we have got the methanol on to the marine market. And that was somewhere between 2013-14. So it's not a new thing. It's pretty well established, even though we haven't really seen the big boom yet. But there is no excuse for anyone to say that technology is not there. We have a system, we have the methanol. Anyway, we were moving on from there. We said, well, now this is done. Let's look for the smaller applications. So we got a project together with Swedish Maritime Administration, where we got to equip this pilot boat with a methanol engine. And we were assuming that we would do the same thing as we did before, naval architects, system integration. And we asked Volvo, Scania about the methanol engine, because we said, you must jump on this opportunity. But there is no really drive from the big engine manufacturers to do anything different. So we got the methanol engine from China. We tested it. It didn't really work out that well. So we did whatever you have to do when developing things. You fill in the gaps. So what we did from there on, we started with our engine development. So what we did, we tried a number of different concepts. The one that we saw what the the best option is this compression-ignited methanol engine. Methanol is not really good fuel from compression ignition because it's more like an auto fuel, but with some tricks you can make it work in a diesel-like way. So we add ignition improver and we increase the compression ratio, and then you can get methanol to work in a diesel-type engine. So what we did, we took this Scania engine, made a conversion to methanol, and we fitted it into this pilot boat. We did the second pilot boat. I will not get into the detail, but in principle, the things you have to change is not that many. So I mean, it's not a big deal to convert a ship to methanol. But we realize we can do it for the Scania type engine. We can make this compression ignited. It's a good. I think that's the best engine we can see, but it's limited. So now we are looking for broadening the market, or to broaden the offer. So then we see that we have to approach a larger market, and that's why we now have introduced this dual fuel system. And all engine suppliers, they will say that we will dual fuel systems in 2027, 2028, and they will have it for their particular engine. We say we will have a dual fuel system on operating in 2024, and it's a generic system that you can apply to pretty much any engine. And that sort of stirs up some activities and makes OEM engine suppliers a bit nervous, which is, I think, good. A dual fuel system, we maintain the diesel system, original diesel system. We add a methanol fuel tank, a pump, a filter, some valves, and then to the injection, or to the air inlet manifold, we add methanol injectors, and then we add our control system. This is now being adopted onto Volvo Penta engines and will be fitted into a pilot boat by the end of this year, and then this will be tested for the Volvo Penta. The concept fuel-wise is really that you keep base level of diesel fuel. What you see here is the red curve is the propeller curve. That's the torque we need to reach at each speed in order to make balance the forces. So we have a base load of diesel, and then we add with the methanol up to what we need for the propeller curve. And different at low speed, at idling, we have all diesel, and at high speed, the diesel replacement is lower. But the typical operation point between 75 and 85% part load, we have a very good diesel replacement ratio. So that's where we need to operate. But important thing here is that we find a way to convert existing engines. So if you have a Cummins, if you have an MTU, or if you have an MAN engine, we can convert that engine to methanol, which means that all existing fleets is now a target for our conversions. Anyway, in the SYNERGETICS project, we will have two engines. We will toe-to-toe compare the compression ignited with a dual fuel. So we will see how it performs, cost of the engine conversion, fuel efficiency, emission, etc. And of course, the objective is to find a way, or how to convert the existing fleets, or replacing existing engines in the most efficient, cost-efficient way. New building, or where you need to re-engine, we would say that, and if within the engine power range we would say that the compression ignited engine is the preferred, but for any other engines, the dual fuel concept is what we think is good. So this is the engine for the SYNERGETICS project, and we are then operating two entities: Scandinav's design, development, and then we have the Enmar engines, which is our engine entity that deliver engines. Enmar engine stands for Environmental Marine Engines, and you can understand how surprised I got when I realized Enmar is reading Ramne backwards. Okay. Thank you very much, and I think we leave the questions for later.
Okay, this was fun. Okay, the next presentation is online from Koen van Heij from Zero Emission Services. Koen, are you with us?
Yes. Can you hear me?
Yeah, we can hear you loud and clear. And we can also see you. We can also see you.
Sharing my screen. Can
Great.
you give a small sound when the screen is on?
Yeah, we see the screen.
I will put it on the presentation mode. Yeah.
Yeah, thank you.
Good morning, all. And I'm sorry to do it in the virtual way. I hope you have had already some good days and time in the beautiful city of Vienna. My name is Koen van Heij. Today I'm replacing the two operational directors of Zero Emission Services. It's a small startup company, and they were extremely busy with getting the next ship under control, so they couldn't make it today. I'm not part of the operational team, but I'm representing one of the shareholders within Zero Emission Services, which is the Port of Rotterdam. And we are proud as Zero Emission Service to be part of SYNERGETICS. I will show you some slides and I will run through it because we all are very enthusiastic about our type. So it will be hard to keep it all in the time schedules. We have almost finished our demonstrator and we learned a lot. And we want to share these learnings within SYNERGETICS. I will show you a bit about some Dutch inland shipping facts. 6,500 ships under Dutch flag, 20,000 tons of NOx, 1.6 megatons of CO2, which is 37% of all transported volumes in our country, and 350,000 tons of transported volume in different modalities within the inland transport. And we have also already for 3 years a so-called Dutch Green Deal, wherein we want to be climate neutral in 2050, and already have, and that will be a big challenge, to already want to be to achieve 50% CO2 reduction in 2030. This is our concept, which the picture says more than a lot of words. It's based on 3 pillars. One is a mobile or modular energy container, which is what we call the six-pack, and infrastructure in a port, where we call it a docking station or a loading or charging station, but the docking station can be utilized to stabilize the grid and to make it possible for a ship owner to pay for its electricity, to have it a sort of similar case as bunkering. We have a pay-per-use system. And the current ship is called the Alphenaar, and it's a relatively small ship, 90 meters, with about 100 tow on board, shipping daily from a small town called Alphen aan den Rijn to Moerdijk, one of our large coastal and inland shipping ports. So back and forth every day, which is about 60 kilometers, so 120 kilometers. And with one battery container, you can do this 60 kilometers. So if there is a docking station, which is currently the case, there's only a docking station, Alphen aan den Rijn, you need 2 battery containers aboard to go back and forth. If there is a docking station, we are in the process of achieving that. In the other part, then you play one of these six-packs, one of these modular energy containers, you play them free, and that's basically the system. Here's some pictures. A docking station has a very small spatial footprint, about 20 by 20 meters. This is one of the containers, which is a 20 foot. This is the port of Alphen, the small port near the huge brewery of Heineken. So most of these containers are filled with beer at the moment. And this is the ship called the Alphenaar. And this is also kind of the rivers where it's going through. And one of the huge advantages also the lack of noise. Now you can imagine that these people are quite happy that this ship is now almost silently crossing the waters. There are some learnings which will be part of SYNERGETICS. And we see a lot of adjacent models where you can improve them, where you can improve this system. If you have a direct line to docking stations from a nearby distribution center, which are a lot of in Holland, probably also in Austria, and you can use the solar cells, the solar cells to load the batteries as well. So you have a direct line, and you don't have to buy green electricity. Shore power might be, we are looking for flexible shore power solution using containers for that. Wind, this is actually in one of the new ports, wind energy, trucking as a combination, because we can use the charging station in a inland port for trucking as well. Probably electrify the reach stackers. These are the opportunities for other usage. This is Holland. This is the tube station map of. We are an enormous inland waterway country, and there are about 50 of these container terminals in the Netherlands and Belgium, all running back and forth to our big deep sea ports, where of the biggest are, of course, Antwerp and Rotterdam, but there's also smaller ones like the Moerdijk, which are sold, Amsterdam, Brugge, these kind of ports as well. And basically they have daily or weekly what we call shuttles back and forth from a inland terminal to a deep sea terminal. And these shuttles, so relatively low distance, relatively not so much stream, etc., so quiet waters. This is ideal for battery usage of shipping. And I don't know the situation in your countries, but in Holland is net congestion is probably one of the largest problem areas we have at the moment. So this could be either a solution, but it's also because it has to be bi-directional. So there should also be grid power in the area. So it's also one of the bottlenecks. The total cost of ownership is, of course, dependent on every different sailing profile, but it's becoming more and more competitive. And this is also one of the main points which I would like to bring forward today, that I told you about the shuttles, that we are also looking for a bit more longer distance. And we see some very interesting cases, especially in combination with other technologies, like the technology which Mr. Jan André is a total expert in, on hydrogen shipping. And I see, because the first slide was talking about this enormous challenge, I see we need everything. So the methanol ships from banked, the battery ships for shuttles, and probably in combination for longer distances with hydrogen, etc. So we are now actively involved with a shipment it's actually from an inland port in Holland called Nijmegen via Rotterdam to Hull, back and forth. And we are looking for solutions along the Rhine to Duisburg or Wesel. And it's always an operational trade-off between time and costs, as you can imagine. We need really to look into every case very detailed, what exactly the energy demand is, and of course what the power demand is on the certain locations. So this is my final slides, that we think that ZES provides a proven modular energy solution for emission-free sailing, not only for shuttles, but also for specific coastal arrangements. And this could help in, and the system, of course, here are some of the advantages. So you can like lower asset investment for our customers. This pay-per-use model, which makes it a bit like the current bunkering system, using renewable energies, and customers can differentiate themselves by showing to the customers that they're really looking for green shipping solutions. So that would be my presentation for today. If you have further questions, you can reach the organization. Of course, I will be part of the panel as well. Thank you very much, Igor.
Thank you, Koen. I visited this docking station in Aachen an der Rhein in June this year. And what struck me, it looks very simple, very common, nothing, no science fiction. It's, you know, they do it day to day, regular operation, no frills, so it's possible. We have seen that all of these things are possible, but then we also want to play the other side. We have Bernard Billinger as our next speaker, who is going to play devil's advocate, and he's going to tell us what can go wrong and what can be wrong. So, Bernard, please.
Thank you, Igor. Thank you also to Danube and to Emmanuel for inviting me here. It's really a pleasure to be here, and you've seen just the presentations from my SYNERGETICS partners. As an engineer, I'm quite enthusiastic about that. As a consulting engineer for customers, my perspective might be a bit different, and to put it that way, now you've seen the good cops, and I'll be playing the role of the bad cop now, because there are a lot of challenges for the adoption of alternative fuels in Danube navigation. The major challenges are distances, energy content of fuels, infrastructure, and of course, costs. If you look at the distances, the Rhine is approximately 800 kilometers long from Rotterdam to Basel. The Danube has about 3 times the length from the Black Sea to Kelheim. The distances of voyages on the Danube are usually significantly longer than those on the Rhine, and the practical applicability of alternative fuels is highly dependent on possible storage volume on board and on the respective infrastructure, which means the distance between the available bunkering stations. If you look at the energy content, we have a benchmark for about 100 years or so. That's diesel. So just look at the last column in colors. 1 would be the storage volume you need for diesel. If you go for battery, you got around 100 times this, for the same energy content. Methanol is quite competitive with about double the volume you need. Hydrogen, just theoretically, if you take it in the let's say atmospheric condition, it's about 3,200 times, depending on how you do it, compressed, cryogenic, or for example, as liquid hydrogen, liquid organic hydrogen carrier, you're round about 5, 7, 8 times of the volume you need for the same energy content. If you look at the infrastructure, you have the Rhine. It's densely populated. It's a highly industrialized area along the entire river. You have a lot of chemical industries along the Rhine, which make the availability of alternative fuels quite probable, and also the reliability of this availability, even, as we heard, as byproducts of something you are doing anyway. There are short distances between bunkering stations possible. The Danube, in comparison, there is a lot of space in between. You have hardly any chemical industry along the river, so hardly any synergies. Anyway, you need sufficiently narrow spacing of bunkering stations, which would be difficult to achieve along the Danube. A general consideration is that a transition from a single fuel environment, diesel, to a multi-fuel environment, methanol, hydrogen, batteries, requires a multiplication of bunkering and storage facilities. So there is, as we already heard, not a one-size-fits-all solution. For the costs, I have just gathered some anecdotal evidence. Batteries for long-distance transport, evidently there is currently no use case. It's just for illustration. In order to replace the average bunkering capacity of a typical Danube pusher, which is about 60 tons of diesel fuel, you would need batteries with a weight of about 1,500 tons. And according to current key information, a total volume of 750 cubic meters, which is about one barge, and an investment cost of about 130 million euro. For hydrogen, if you go for pressurized 20-foot gas containers, the costs, perhaps Jan will correct me here, is about 300 to 500,000 euros. It contains about 1 ton of hydrogen, which is equal to approximately 3.4 tons of diesel. So to get the same bunkering capacity, you would need approximately 18 containers. So, which I want to say with that is, if you go for these alternatives, you really need a very dense spacing of bunkering or swapping facilities for these containers. What could we do? Batteries, probably suitable for local passenger traffic, day cruises, where you also have an influence on the available infrastructure. Methanol, hydrogen is first of all a hen and egg problem with regard to the infrastructure, because ship owners will not invest as long as there is no sufficient bunkering infrastructure, and bunkering companies will not invest as long as there are not enough vessels using alternative fuels. So again, if you're a shipping company that has a certain influence on the infrastructure, might be a viable alternative. So if you can set up your own bunkering infrastructure because you have a point-to-point relation, might be possible. Then there are further challenges. We have heard from, in particular, Jan and Bengt, many of these challenges. There are already solutions. There are approaches to mitigate the potentially dangers. For example, methanol is toxic. It mixes with water, can be a hazard to persons and the environment. Hydrogen, for example, in its cryogenic form is extremely cold. It's close to the absolute zero. So it could be, in case of inadvertent spillage, a hazard to the structural integrity of the vessel in case of spontaneous embrittlement. And of course, we have the issue of crew qualification. You need highly qualified crew to appropriately use these alternative fuels. Are there more alternatives? At the moment, one of the most promising alternatives from my point of view, as I said, as a consulting engineer, could be HVO100. It's a second generation biofuel. It leads up to 90% reduction in greenhouse gases immediately, depending on the way it is produced. It's already approved for use by many major engine manufacturers. The diesel infrastructure can be used on board as well as shoreside. What about the availability? Not so much of a problem. Diesel can always be used as a fallback. HVO100 and diesel can be blended in any proportion, so there is no problem if you, for example, somewhere down the lower Danube, you don't get HVO100, you can just take the usual diesel that is available everywhere. Could there perhaps be also synergies with the transport of agricultural products, which is quite some commodity on the Danube? can residuals and byproducts be used as a basis for HVO 100 and create their own business case in that respect? So you see there are still lots of challenges for the use of alternative fuels. I'm, as I said, as an engineer, very enthusiastic about all those technological developments. But if a customer asks me today, I would say, go for it, grab a contract with someone who can supply HVO 100 for you, and then think about it, take your time to think what you really want to do in future. Thank you very much.
Okay, so shall we bring the... Good. Yeah. So, may I ask what do I do? Yeah, okay, good. Okay, questions, please. And please do me a courtesy. When you ask a question, please introduce yourself. Unless you're Robert Raphael, do not suppose that we know you. Okay, please, go ahead. Yeah. It's coming.
Very interesting project and very amazing presentations. Thank you. Just two quick questions. One, in every meeting about decarbonization of deep sea shipping or short sea shipping, you have methanol, hydrogen, batteries, and ammonia. I was kind of surprised that I didn't listen ammonia. I came a bit late. Maybe it was mentioned at the beginning. This is one of the questions. The second, regarding the biofuels, is almost not considered seriously for deep sea ships. It's discussed, but not, as I said, these three are the ones that are discussed because of the land use that it requires and is competing with other industries. Do you really think that this could be viable, maybe as a temporary solution, as you said, for these coming years, maybe, but not for a long-term solution? And just if I can make a last one very, very quickly, shore power. Shore power is being implemented, is the only policy in the Green Deal by the European Union, and it's receiving plenty of funds, and many ports are installing now. But it's being discussed that if the ships of the future are going to be with ammonia, with methanol, with hydrogen, then they could become stranded assets, because then you have ships arriving to the city ports and not generating CO2 emission, not generating air pollution. Of course, there is the issue of noise. What is your take about this issue of shore power, because it's huge investment for each port, not the final connection, but the infrastructure, the connection to the grid? These three, sorry.
I see three questions there, right? So one is ammonia, one is HVO, and one is shoreside power, right? Okay. I try to answer some of these, and then, of course, I ask you. So as for ammonia, this call contained a very specific requirement that we were supposed to reach out to the low-hanging fruits. And ammonia is not exactly a low-hanging fruit for inland navigation. But on the other hand, we are exploring the utilization of ammonia. In Germany, we have a huge landscape of projects which are looking into, among other solutions, also the ammonia. And this is also, we are going to create a synergy with these projects, with national projects in Germany, who is very keen on developing of usage of ammonia. So it's not totally excluded, but it has some limitations when it comes to synergetics. Then regarding the HVO, there is one, other people may know more than me, but there is one impediment there. Who is going to have the priority when it comes to use of HVO? And what we know and what is being said is that the aviation will have the priority there. So again, not excluded, but we also need to be aware of the limitations. For the shore side, I cannot answer. If anyone else can answer, I would be happy.
I can probably say something. Oh.
Yeah. Koen, please.
Yeah, no, just a remark from, let's say, from the Port of Rotterdam side, is that I understand the question, but basically the short answer is we have to do all to get our targets. So there will be specific usage for shore power, and there will also be all kind of projects for ammonia, ammonia loading and ammonia storing, and pipelining, etc. But so there is, for a port, the challenge is to have them both. So to do all.
Yeah, a couple of comments. I think HVO, of course, that's an attractive fuel. It's a drop-in fuel, but I think you will be difficult for anyone to find a supplier who will provide you with HVO long-term in large volume because it's very limited. So our preference for methanol is based on that is the fuel that is easiest to scale up with sustainable production, and the yield from original energy to fuel is the best. So that's why we sort of believe in methanol. Ammonia, of course, it looks attractive because it's a zero emission end of pipe. But if you look into the full well to wake emissions, there is really no benefits with ammonia. And then, of course, it's dangerous and it doesn't really work that well in combustion engines. It's very difficult. Shore power, we have a lot of requests for methanol generators for shore power. So that's a recognized problem that everyone likes shore power, but the infrastructure, the grid is not there. So that has to be, if you want to have renewable, clean shore power, many places it has to be produced locally.
Ammoniac we also investigate. It's an interesting possibility to transport hydrogen overseas and for seagoing ships as a hydrogen, as an energy carrier. There are in Port of Rotterdam, there are storage capacities where you can land on the ammonia, transport along the rivers and then distribute and crack on site. So ammonia cracking. Ammonia the price will decrease in the future because many countries see the possibility to use ammonia as energy carrier. So, but that's where we concentrated on is what is available today. So I think perhaps in 2 or 3 years there will be solutions with ammonia engines, but I agree that's a complex technology which is not yet validated, and the risk, of course, of ammonia is on a seagoing ship is not negligible.
Okay, we have a question there.
In the meantime that Dejan gets the mic, yes. Let me combine a few questions from the online audience because there are quite some. Actually, I think Bernhard is now excluded from this question because he already gave some answers and challenges on that. But different type of questions, but let me summarize it in a way. We see things happening here and there, but what is the real, from your technology provider perspective, what is the real hurdle, or what are the real hurdles, why they are not happening in the wider range? And looking at the list, it's more or less for all applications. There is also specialty that some things are happening in the maritime. Does it have, like methanol, does it have a real chance in inland at all? So long question short, what are the real challenges? Why is it not being spread faster and wider?
Yeah. We've been pushing methanol for more than 10 years, and we can see that there is an interest, huge interest, and there's an interest to make demonstrators because to show that you do something. But it's still very difficult for any operators to build a business case around alternative fuels. So the sad thing is that conventional fossil fuel is still too cheap. So it's very difficult to make anything compete with that if you need to run it on a commercial terms.
If I may add one thing, what we have learned also from the database, so this pilot database, by far the most pilots are being executed on, say, vessels which have low power demands, and they operate with operational profiles which are not changing much. We are talking about day cruise vessels, ferries, small ferries, and so on. And this means, actually, if we try to translate it this why and to understand why, actually the risk is low. From the business point of view, the risk is low. So short distances, very limited power demands, not many changes expected. You can provide for supply, and that's where the most pilots are going. So there is a reluctance from the ship owners to invest into a higher risk end.
Perhaps some additional aspects regarding HVO and also to the shore power. I have quite recent information just from yesterday that from the cost perspective, HVO is about double the price of conventional diesel at the moment. And of course, the limitations mentioned, there will be a competition. Who is going to use HVO? That's why I just said in my presentation, go and grab a long-term contract. With regard to shore power, of course, that's an issue on inland waterways. It's a big issue, in particular with reference to the cruise industry. Of course, you have a lot of spots, the beautiful spots in the landscape with small villages, picturesque landscape, and so on. And the cabin vessels want to go there, of course. And they are not very popular from some perspectives, because with all the transits running overnight, the neighbors are not happy with that. So the demand for shore power in these regions is high, and in Austria, the Waterway Management Agency is actively promoting this and supporting this, but the power you need is not really low for operating such a cabin vessel with all the air condition and the kitchen and the comfort for the passengers. So sometimes you have the challenge that if you plug them in, the vicinity goes dark. So you have to make sure that the grid behind it is powerful enough. Thank you.
It goes romantic. So we had a question there.
Yes, short question, and please for a short answer.
Please use the microphone and please introduce yourself.
Yes, Dejan Trifonovic, Danube Commission Secretariat. One word is missing when we discuss about hydrogen, green hydrogen. What type of electricity will be for the hydrolysis process? And it will be green energy produced by photovoltaic and wind, or for fossil fuels and steam power plant and nuclear power plant? Thank you.
I think if you want to have really green hydrogen, then of course offshore wind park or wind park energy, photovoltaic energy is the best way to use it. It's interesting also, especially in Germany, where we want to install more and more wind power, but the grid will not be able to absorb it. So hydrogen as energy storage is an interesting possibility. And then bring it via pipeline. We recently found out that the old natural gas pipeline is completely suitable for the transportation of hydrogen. 99% of the pipeline installed in Germany. So you could imagine that having big electrolyzers on the North Sea and Baltic Sea, and then pipelines bringing the hydrogen to the regions where the energy is needed, and then you have a full green hydrogen production.
It means calculation made by basis of green hydrogen.
Yes.
Okay.
Yes.
Yes.
So I just want to add to this point, and what I find it's quite depressive, because I'm Igor Schauper from LEC, so we are colleagues of Bernd, and we are also developing these technologies. What is depressing is actually the availability of green energy in general. So, and my question would be, do you think that your project would have a kind of impact to boost the? I mean, this is obvious that there's a lack of green electricity, for example, and I don't think that this 10-cent cost for electricity that you are using is green, right? Oh, for 10 cents you are. Yeah, and do you have then the special agreement with the provider?
Yeah, that's exactly. We are currently negotiating offtake agreements with wind park energy companies and long-term contracts. That's what was said before with 10 cent. and then use this green energy to produce hydrogen.
But most probably the volumes or is limited. I mean, you cannot cover the whole Europe with this. Yeah, I mean, you know, this is always the question of availability, right? I mean, HVO, some can have the access, the others don't. What this methanol is concerned, I mean, this Maersk is demonstrating what is the way that they organize also the supply chain themselves, and they have then access to this. So this is, I think, also the challenge, how to get the access to this green energy for a reasonable price.
I believe that renewable energy will be 2 to 3 times as expensive as fossil if you scale it up. Not maybe today you can find cheap, but if you scale it up, it will be 2 to 3 times as expensive as fossil. And then you have to find, and the good thing, well, that's a bad thing. The good thing is that society, we can sustain. I mean, we can run our transport on renewable fuel. The society will not collapse. So there just need to be a business model and push that we need to do it. But it will not be cheap to go renewable. It will never happen.
Okay, can we accommodate one more question?
Can I?
Please. Sorry, Juha. We have. Yeah.
Thank you very much. My name is Vedran Klisaric from Croatian Register of Shipping, from Croatia, obviously. And we are a small classification society, but we are also a member of International Association of Classification Society, and also we are recognized from European Commission regarding Directive 216/1628, and we are glad that we are part of this very nice project, SYNERGETICS.
Which is more important than Ajax?
We will see. I'm joking, yes. And I have 1 or 2 questions for... Okay. I will try to merge. Yes. One question is, if we looking on the zero emission technologies, how the HVO fuels fit on that? That is question for Mr. Bringer. And another question, I will try to explain shortly. We saw all these beautiful technologies, but during the development of that technologies, did you work with some regulatory body or classification society? Is that the scope of work mostly in maritime navigation, and how do you plan to implement in the inland navigation? Because as we saw, we have a lot of challenges in Danube region more than in Rhine. Thank you very much.
To your first question, to the best of my knowledge, what you can find on publicly available sources, if you use HVO, you have immediately a CO2 reduction of about 90%. The residual is the production process. So if you can also, let's say, green the production process, you can come closer to the zero emission goal. That's a question that still has to be solved. But for the moment, as a drop-in fuel, as mentioned, I think it is a very interesting alternative, because you get a big reduction in CO2 emissions almost immediately.
Second question, yes, we are during the prototype phase. Of course, we have to work with the classification bodies like Lloyd, DNV, Bureau Veritas. We have not experience with your or RINA, but that's the starting point, that you have them in from the beginning, so you get a certifiable product, and they have to learn, we have to learn, so we are learning